How's it, grade 11? So we're still busy with mathematical induction, and I hope the last bit of homework was okay. So with this type of examples that I'm going to go through is that we're going to prove that something is divisible by a number. Okay, so with those previous examples, we proved that some little expression would be equal to the sum of these other terms. Okay. And so those are the two types of problems that we get. We get the one where the sum is equal to some kind of an expression, and we get these types here where we have to prove something is divisible or a factor. Okay, so if we look at example 5, and guys, if you want to know in your books, I am working from this chapter here. Okay, chapter 9, algebra, grade 11, mathematical induction. Okay, so from your examples there, example 5 is saying prove that 3 is a factor of n cubed plus 5n for any natural number n. In other words, if we choose any natural number for n, plug it into here, it should be divisible by 3, or 3 is a factor of it. Okay, so the steps are exactly the same. So step 1, we have to prove true for n is equal to 1. Okay, so if I put 1 in here, we get 1 cubed plus 5 times 1, and that gives us 1 plus 5, which is 6. Now 6 is divisible by 3, therefore divisible by 3. In other words, it's a factor. 3 is a factor of 6. Okay. Number 2, we have to assume true for n is equal to k. All right. In other words, k cubed, and I'm just going back to here, plus 5k is divisible by 3. All right, then step 3, we have to prove true for n is equal to k plus 1. So these 3 steps, 1, 2, 3, is exactly the same as those other examples. Okay, the only difference comes here with the step 3, how we prove it, if it's divisible or not. Okay, so what have we got here now? So now I'm going to go back to this original, or this one here, and this one, and I'm just going to make it k plus 1. So we get k plus 1 cubed plus 5 k plus 1. Okay, so I just made the n k plus 1. What I'm going to do is I'm going to multiply this out. So just remember that this is 3 brackets together. Okay, so you'll have k plus 1 times k plus 1 times k plus 1. You'll have to FOIL it out 3 times. So if we do that, we get k cubed plus 3k squared plus 3k plus 1. Here I'm just going to distribute the 5 in, so we get plus 5k plus 5. Okay, just get like terms together, and just to simplify it, so we get k cubed plus 3k squared plus 8k plus 6. Okay, so what I'm going to do now is, over here I can see that I have this k cubed plus 5k is divisible by 3, and I'm going to try and look for it in here. All right, so here's the k cubed bit, but we're just missing this 5k bit. Now that 5k bit I'm going to get from this 8k, and how I'm going to do it is I'm going to split that 8k and say that it is 5k plus 3k. All right, because then that k cubed and this 5k will be divisible by 3. Okay, so that's all I'm going to do, grade 11s, is I'm going to split the 8k to be 5k plus 3k, and then group them together. So we get k cubed plus this 5k, okay, and then what am I left with? I'm left with this plus 3k squared, and I am left with a 3k plus a 6. Okay, now this thing here is divisible by 3. Okay, and if I have a look here at this last 3 terms here, okay, we now need to prove that this thing is divisible by 3. But I can see that 3 is a common factor, so I can take the 3 out, and because 3 is a factor, therefore it must be divisible by 3. So I'm just going to show that. Okay, so this is divisible by 3, so I can just state that. So I can say k cubed plus 5k is divisible by 3. And 3 is a factor of this, okay? And 3k squared plus k plus 2, where 3 is a factor. All right, therefore, sorry, I'm just have to squeeze it at the bottom here. Therefore, 3 is a factor of this entire thing here. N cubed plus 5n. All right, then going on to the next example, which is example 6. Same thing, where we have to prove something is divisible. Okay, so it says that prove that 9 to the n plus 3 is divisible by 4 for any natural number n. So step 1, prove true for n is equal to 1. Okay, so if I put 1 in here, we get 9 to the power of 1 plus 3. 9 to the power of 1 is 9, plus 3 is 12. 12 is divisible by 4, okay? Therefore, divisible by 4. Okay, step 2, our assumption. Assume true for n is equal to k. In other words, we are going to get 9 to the power of k plus 3 is divisible by 3. Okay. Step 3. Now we have to prove true for n is equal to k plus 1. All right, so I'm just going to make that a k plus 1. So what we have to do here is 9 k plus 1 plus 3. So now we need to prove this is divisible by 4. Oh, sorry, this is not a 3, this is 4. My bad. Okay, so what I'm going to do here is just use our exponential laws and just split this, okay? You know your exponential laws, if it's a to the m times a to the n, if bases are the same and you're multiplying, you add the exponents. All I'm going to do is just reverse that. So we get 9 to the k times 9 to the 1 plus 3, okay? So what this is saying actually what we've got here is 9 times 9 to the k plus 3. All right. Now I'm going to come back to this, and what I want is I want 9k plus 3 because I know that's divisible by 4. But I don't have a 1 9k. I've got 9 of them. So what I'm going to do is I'm going to split this to be a 1 9 to the k plus 8 times 9 to the k. And that will give me my 9 times 9 to the k. And we get here, so I'm going to make it this one, 9 to the k plus 3, because I'm just going to group them, okay, plus, and what am I left with? 8 times 9 to the k. All right. Now, we know that this is divisible by 4, all right. This I'm just going to show is divisible by 4, so we get 9 to the k plus 3 plus 4 times 2 times 9 to the k. Okay, and because 4 is a factor, it must be divisible. All right, so we know that this 9k plus 3 is divisible by 4. And 4, 2 times 9k. So when you see him, where 4 is a factor. Okay. Therefore, 4 is a factor of 9 to the n plus 3. All right, grade 11. So what I would like you to do for the homework, it's just the exercise after that. You can do questions 5 to 8 for me. Okay, so your homework, questions 5 to 8. Thank you.